So today I will present about the introduction of the project. Geological research is the foundation of geomechanically categorization, which is critical for understanding and managing rock mass in engineering projects. So this procedure entails extensive mapping and investigation of geological characteristics such as rock kinds, structure, and discontinuities. So identification and distribution of rock types are important components of geological investigation in this context. So structure, for example, faults, joint, folds, and other structural characteristics are being mapped. Discontinuities characterizing cracks like bedding planes and fault that can.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abu Hanifah bin Muhammad and my metric number is BFC21303. So it's my turn to explain about the methodology. Okay, the first one is how to determine the type of rock point loop. So by our investigation, found a variety of layer rock in the area, which mudstone, the greenish grey, formed underwater from clay. That been the most common. So this rock that include the sandstone, mudstone, concrete, shale, sandstone, and limestone. Okay, second, how to identify the weathering grade and classification. So the field of geologists categorize rock weathering using a system that is ISRM 207 with grade range from fresh rock 1 to completely broken down soil. And they identify the weathering process like oxidation and root growth and assess the grade by fracturing rock with the hammer. Okay, next, how to identify the geological structure. We identify the geological structure that including the fault, fold, joint, and variation in rock strike and dip. This indicates deformation, there is a movement and tilting of a earth crust that potentially with a rock type of variation. Okay, now how to determine the dip angle and dip direction. So basically we use a Brunton compass to determine the angle and direction of the rock layer. So by placing the compass flat on the level layer, we will find the direction, the line where the layer meet the horizontal line, and then we rotate it 90 degrees and leveling it again on the side of the layer that will reveal the dip angle, which directly measure how steeply the layer is tilted. Both dip direction and dip angle are then recorded for the further analysis. And now for a rock mass in situ test using a schemic rebound hammer. So to assess the rock strength on site, a schemic hammer is used. Okay, the first one, how to use it is press it firmly against a flat surface, trigger it while maintaining a steady contact, and then record the rebound value display on the screen. Repeat this process at multiple rock location, and then taking data of each rating. Okay, the last one is the point load test. So the point load test squeeze a rock sample between the conical point until the rock fracture. So after setting the sample and making the initial contact, the load is gradually applied until the rock break. So the force at failure, which is a P, is then recorded and analyzed to assess the rock strength. So that's all from me. Thank you.
Okay, so now I would like to present about data analysis and result. For the first one is determination of rock formation and type. Definition of rock: composite substance made of one or more mineral or mineraloid. Second is naturally occurring solid aggregate. And next is category of rock. The first one is igneous, sedimentary, and metamorphic. And the last is for rock texture. Provide information about parent material, deposition condition, crystallization history, and geological change. Okay, next is about determine and chart the rock outcrop weathering grade. They have 5 grades. For the first grade is no sign of deterioration apparent. Grade 2 is there is some wear and staining on the granite along with sign of decomposition. And grade 3 is there are noticeable indication of discoloration and mud weathering on this granite boulder. Grade 4 is there is considerable discoloration and breakdown due to the granite extreme weathering. And grade 5 is the original bulk of the building is still despite all of the rock weathering being damaged. Okay, next is about investigate the geological structure. The first one is fault. Display rock fracture caused by neighboring rock mass sliding past one another as a result of shearing, compression, or tension thrust. Next is joint. A fracture or crack in rock where there has not been any movement along the fracture planes is called a joint. Next is formation. Planar fracture of metamorphic rock include sedimentary rock layer and the orientation of mineral grind. And the last one is an important geological structure that lies between two rock layer or sequence with difference deep is called unconfirmed. Okay, next is field and laboratory testing. The first one is project overview. 3 experiments were conducted during the 3 Mersenne project. And next, checkpoint analysis. Data and analysis at the first checkpoint, commercial industry air hitam are presented. Rock at this checkpoint are exclusive of volcanic igneous rock. Next is experiment conduct. Smith hammer test. Purpose determine rock hardness using the rebound hammer method. Result unaxial compressive strength UCS is 40 MPa. Average rebound hammer value data result display in table 4 and figure 2. Next is pilot test, purpose to determine the index strength of rock using steel conical point. Result average, correlation point dot test, IS15, and UCS value display in table 5. And the last one is slate durability test, purpose to determine the numerical durability value of weak rock. For the result, slate durability index value range from 70% to 80% after 2 seconds. Conclusion, rock is categorized as having very low durability due to increased weathering exposure. Okay, next for the field and laboratory testing. So the first one is PMR system overview, developed by Benesworthy in 1976 for rock mass classification, also known as geomechanics classification. Next is data collection. 2 times area 2 times 2 meter rock was selected for data collection using the windowing method. The third one is first checkpoint analysis, location at kawasan industri air hitam, classification method RMR system, and the last one is perimeter for PMR classification. 5 parameters are used for classification. Okay, next is unaxial compressive strength of rock material and spacing discontinuities. By using the graph of UCS versus SRV, where the SRV is derived via the Schmidt-Simon test as shown in table 7, one can calculate the unaxial compressive strength UCS based on the average value of the rebound hammer SRV. So the data and the result have shown below.
Now we are going to the next part, which is condition of discontinuities and groundwater condition. Discontinuities condition was determined based on the 6 categories. First is persistent, which is 1 to 3 meter long. The second is aperture joint opening, which is more than 5 mm. Next is roughness, which is smooth. The fourth is infilling gap, which is hard filling, more than 5 mm. And the last is weathering, which is highly weathered. For the groundwater condition, is completely dry. Now we are going to the next part, which is total rating. The class number and description of rock mass are classified as a total rating. There are 6 item values that we need to get the RMR value, which are unaxial compression strength, drill core quality, spacing of discontinuities, condition of discontinuities, and groundwater condition. The RMR value of unaxial compression strength is 7. For drill core quality is 17. For spacing of discontinuities is 20. For condition of discontinuities is 20. And last is for the groundwater condition is 15. And the total of RMR value is 79. Based on the guideline for excavation by RMR system, we get our rock mass class is on a good rock, which RMR value is 79 between 61 and 80. Now we are going to the next part, which is structural geology data. Discontinuity data at the first checkpoint in kawasan industri air hitam was collected using the Mountain Compass and the scan line survey based on ISRM 2007 guideline. There are 30 points of discontinuity data at kawasan industri air hitam. Based on that data, we can create the contour of structural geological data. So based on the contour that we create, we get the 6 of joint set which have different deep direction and deep angle. Based on that deep direction and deep angle, we can create the great circle to analyze the failure mode.
So, my name is Muhammad Azmi. I want to talk about conclusion. So, as conclusion, the geology excursion provided every student with valuable insight and a deeper understanding of engineering geology, both in theory and practice. Visiting locations like Air Hitam, Seri Mesing, Pantai Air Papan, and Pantai Seri Mesing alone us to identify various rock types and comprehend their significance. So we gain proficiency in using instruments like compass, enhancing our ability to locate joints and folds accurately. Moreover, we learn about the geological framework and analyze the engineering implication of civil engineering projects. Exploring concepts such as weathering, sedimentary, metamorphic, and igneous rock, as well as mass movement activities, provided a comprehensive view of geological process. Despite the challenges, this hands-on experience fostered teamwork and taught us invaluable lessons in practical geology and engineering assessment. So overall, the excursion significantly expanded our knowledge and skills in geology and its application to engineering projects. So thank you. That's all from me.